So in the first half, as I said yesterday, you have got a deep intuition regarding what exactly neural networks is, which is very basic and it is important for learning advanced topics like what we are going to cover it today. So today's agenda for the first half would be learning CNN, that is convolution neural networks. So in the first, we will cover what is exactly convolution neural networks, what are the layers, different kind of layers which are there in convolution neural networks. Then we will be dealing with feature selection. Then we will show you some of the CNN projects that we have done in our students' life. And again, we will be also giving you an intuition and depiction about online projects, some of the online projects which are there regarding convolution neural networks. So welcome today again on the second day of MLFest, and I hope you guys have enjoyed and you are excited to learn convolution neural networks. So you might have been thinking this is a very big word. What is exactly convolution neural networks? But believe me guys, once you understand the basics of convolution neural networks, once you get all the things cleared, you will be feeling, you will have much more interest, you will develop interest in this CNN topic because it deals with images. So in this slide, you can see that there are there are two images. Okay, so you can see a bit difference between these two images. I hope you and me, even all of us, to have some of the picture editing, photo editing apps, isn't it? Like Photoshop or Pixar, something like that. We do apply any filter to that image, to our image or any image. Okay, what exactly happens when we are applying any filter? Have you guys ever thought, means how the process is taking place? What exactly the process takes place when we are applying that particular filter? The image distortion takes place, means color distortion takes place. Have you ever thought about this? So if you have thought, then what is it? What exactly happens? I'll tell you. See, this is nothing but an image, okay, and the same image is given over here, but you can see a bit saturation of that image. There is a bit saturation of color in this image. So what happens here? Here, whenever we are applying any filter at that time, there is a multiplication of a matrix. We call it as a filter matrix in technical terms. So whenever we are applying that filter matrix over the image, the color distortion takes place, or the changes in that particular images takes place according to that filter matrix that we have applied. So the same concept is there whenever we are trying to edit an image. And the same filtering concept will be helpful when we are going to learn convolution steps or convolution neural network. So this is why the filtering operation is important, and we will be seeing in the next slide how the filtering is been taking place and how the convolution layers are able to extract the particular feature. So let's go. So before getting deep dive into what exactly convolution operation is, first you need to understand what an image is. It may sound ridiculous, but what an image is very important. So you can see that this is a color image, okay, and this is nothing but a black and white image. We call it as a grayscale image as well. So what happens to this grayscale image? The grayscale image is nothing but a matrix of a pixel values. So you know that pixel is the smallest unit of any image. So the value of a pixel determines the color of that pixel. As you can see on the left hand side, these are the pixel values. Okay, take into consideration this is the 0 value. Okay, so this 0 value corresponds to the black color, and hence this pixel has got black color. See, now this is the 255 pixel value is 255. So the color corresponding to the 255 would be white. So pixel values are between the range of 0 to 255. 0 determines the black color, means the blackish shade, and the white color is represented by pixel value 255. So between the 0 to 255, we have pixel values of an image. So you can see the rest of the pixels over here, they are having some shade between black and white, like grayish and light grayish. So these are the pixel values corresponding to them between 0 to 255. So this image representation is very important, and this was about grayscale image, or we call it as a simple black and white image, which is nothing but a single matrix of a pixel. But what about a colored image? Usually we deal with colored image mostly, and colored image is nothing but a combination of three matrices, namely red, green and blue. Okay, so you can see these three matrices are they are called as a channels in technical terms. So these are the channels, they are nothing but the matrix of pixel, isn't it? So they combinedly together form a color image, as you can see over there. And this image is again divided into pixel. That is, a pixel is it has dimension of 5 cross 10, means 5 rows and 10 columns. So hence it has dimension of 5 cross 10. And we call it as a 3-channeled image. Colored image is called as a 3-channel image. Why? Because there are 3 channels. Channels is nothing but a matrix, 3 matrix representation. A color image is a representation of 3 matrix. So that is the basic difference between colored image and grayscale image, and how the pixel values are determining the color of any image. That is very important. So let's go further. So we have seen what is an color image. Okay, so we have here the image. This is nothing but a color image. So how you can display this image with the help of a Python code? That is a simple thing. So we have to import some of the prerequisite libraries like NumPy, Pandas, Matplotlib, CV2. Okay, and we have to give the path of the image, that is car1.jpg. This is the path of this particular image. We are using the imRead function of CV2 in order to read the image. Then what we do, we plot that image with the help of plt.imshow function. And once we plot that image, we are getting this representation. So you can see that there is on the vertical side, there are pixel values, means its pixel values might be ranging from 0 to above to 175. And on the horizontal side, you can see from 0 to more than 250. So it has, these are nothing but a pixel values. And in this data, what we have passed, that is as array function. With the help of as array function, we have passed the pixel values of this image into this data variable. So whenever we are printing this data variable, you can see that you have got a 3D matrix, 3-dimensional matrix, and these are nothing but the pixel values. Pixel values corresponding to a particular region of that image. So all these are the pixel values of this image. So this was the introduction to computer vision. So this is just the basics of computer vision. Before getting into what an age detection is, I would like to give you one small representation. See, this is one very interesting site. And you can see over here on my left hand side, I'm having one input image. Okay. And on my right hand side, there is an output image. And I'm just hovering over the input image. And as I'm hovering over the input image, you can see the middle values. These are nothing but the pixel values corresponding to that red region, which is highlighted in the input image. So these are those pixel values. As I'm hovering over the input image, these pixel values are getting changed, isn't it? And whatever the output I'm getting, on what factor this output depends, how this output has came. So it depends upon these particular values that we are multiplying with the pixel values. So what it is called as, so these values like 0, -1, 0, -1, 5, -1, 0, -1, 0, this together is called as a filter matrix. Okay. So according to this filter matrix value, the output image will get changed. Okay, so you can see that this now I will change this filter matrix to see. I have changed it to the left Sobel. Okay, the filter matrix, that is 1, 0, -1. These values have changed. However, these pixel values will remain it is the pixel values of input image. And this particular values, means the kernel, or we call it as a filter matrix, will be applied on this entire image in order to get the output image. So output image is getting changed according to this filter values. Now you can see in the output image, these vertical lines are more highlighted, isn't it? See, and if I change again this filter matrix, now see, you can see that in the output image, these horizontal lines are more highlighted. See, you can, yeah, I hope you have got the point that how the changing the filter matrix would change the output image. It means that it is trying to extract those features, those particular regions. It is trying to extract those particular regions. So this was the, the visualization of what exactly filter is. We will get a deep intuition regarding that. Don't worry. So see, in this age detection, you have seen that how the filter matrix is changing the output image or output feature map. We call it as a feature map. Okay. Suppose that you are having this image. Okay. And you want to detect vertical lines over it. Okay. What you will do? Suppose this is nothing but a image matrix. Okay. And this is the filter matrix that we have applied over there, as I shown you in that particular visualization. So how does it applies to this particular image matrix? What we do exactly, we take this filter matrix, on the top left corner first, okay, we keep it on top left corner, we do multiplication and summation. So see, first we will consider this first column of this 3 by 3 region, and the second first column of this filter, we do multiplication. Likewise, 5 into 1 is 5, plus 5 into 1, plus 5 into 1. So what would be the result? 5 plus 5 plus 5 would be 15. Okay. Again, consider the second column of that region. Consider the second column of this region. Do the multiplication. 5 into 0 plus 5 into 0 plus 5 into 0. That is nothing but 0. Consider the third column of this region and third column of this filter. Then 5 into minus 1, 5 into minus 1, 5 into minus 1. Addition of this 3 would be minus 15. So multiplying first column with the first column of filter gives you 15. Second column with the second column of filter gives you 0. Third column with the third column of filter gives you minus 15. So overall, summing up this, 15 plus 0 plus minus 15 would result into 0. So we have got the final output after applying that filter matrix over here as 0. Okay, so we append that 0 here. Similarly, we take this filter and apply it on the next region, leaving behind the first column. Now we will exclude this first column. We will apply that filter to this region. Okay, this again we are performing the same operation, that is convolution operation, a summation and multiplication. Summing up like 5 into 1 plus 5 into 1 plus 5 into 1. Okay, that is 15. Again, multiplying this column, this column with the second column will result into 0, since this is a 0. And again, multiplying zeros with minus 1 will result into 0. So we have got output as a number, that is a bigger number, because first we have got 0 and this is nothing but a bigger number. We call it as a bigger number rather than 15. Okay. So now next here we are considering this region. And similarly, we consider this next region and perform the same operation of filtration. We continue the steps. Again, we will continue by taking into consideration this region, leaving behind the first column, first row, and the operation is taken place until we reach at the last region, last 3 cross 3 region. Okay, so what we get in the output, that is very important thing, because what the output matrix signifies is very important thing. You can see that this the bigger number, you are getting output as a bigger number whenever you are applying this matrix, filter matrix, over this particular region where the gradation is there from white to gray. We are getting what? Bigger number whenever we are applying matrix to this particular region, in this particular region. So what does this signifies? See, whenever there is a color gradation from white to gray, at that time we are getting output as a bigger number. Okay, so these bigger number signifies that yes, the feature that we want to detect in that particular region is present over there. And here the 0 number signifies that that particular region, it does not has a color gradation. Okay, so you can say that this region, you can see this region, it is gradation from white to gray, and you can see this vertical line. Okay, so what does this says that these 15 values are stacked vertically one upon another, and this says that there is a vertical edge. Vertical edge is present over there. So this particular filter that we have applied over there is nothing but for detecting the vertical edge in the image. So you can see this is the image. Okay, and if you apply this you apply this filter over this image, you can get the output like that. So in this, vertical edges are more highlighted, isn't it? You can see more vertical edges are getting highlighted and they are like extracted from that image. Similarly, if you apply another filter for horizontal detection, horizontal edge detection, you will get output as this image once you applied it on this particular image. So as pixel values, you know, it is from 0 to 255. But in the filter, we have used -1 as well. So why we have used -1? So regarding that, I'll just go on the Jamboard and we will get intuition regarding why we have used -1 as in our filter. You can see in this, that is, I have consider this is nothing but an image matrix. Okay. And this is a region in which we have to detect a cross. Okay, cross means like cross line we have to detect in this region. And we have two filters, this one filter and this is another filter. So what we are doing right now, we have the cross filter for, we have cross filter like here zeros are stacked. The only difference between them is like here zeros are stacked and here there is -1 in the region where we are not detecting the cross filter. So here there are one common and one is also common over here. So what we do, the same convolution operation we will try to do, and we will try to find out which is the best filter to be applied on this region. Which after applying which filter, we will be able to detect the cross in this, or whether the cross is present or not. Okay. So take into consideration this first column and this first column. Do the matrix, do the multiplication, that is 10 into 1 plus 15 into 0 plus 10 into 1, that gives you 20. Okay. Again, do the same thing for second column and second column. 0 into 15 plus 1 into 10 and 0 into 15. So what output you get? 0 plus 10 plus 0, that is 10. Do the same operation with the third column. Okay. So what output you will get? 10 into 1 plus 15 into 0 plus 1 into 10, that is nothing but 20. Sum up all this, you will get 20 plus 10 plus 20, that is nothing but 50. Okay, now this is nothing but this, whatever output we have got is a bigger number. So as I told earlier, a bigger number signifies that the feature that we want to extract from this region is present. Okay, so by applying this matrix, this filter, what it tells us that yes, that particular cross is present in this region. But whether it is present, that is the question. Now, if we apply this filter, okay, we will try to apply this filter by taking the same steps, that is first column and first column, multiply it 1 into 10 plus 15 into -1 plus 1 into 10 will give you output as 5. Similar operation is performed with second column and second column. You will get as -20, and do with the third column as well, third column and third column. You will get 5. Okay, sum and you will get answer as -10. So this is nothing but a negative value. So we are getting two different values by applying two different filters, but both the filters are for detecting the cross only. Okay, so which is the right filter then to be applied? How we could know? See, this filter, after applying this filter, it is only taking place the cross values which are there in this region. Only it is considering these values. It is not considering what are the adjacent pixel values, isn't it? But we need to consider adjacent pixel values as well. Why? Because it will determine the color gradation. Okay, if we won't consider adjacent pixel values, how we can determine what is the color gradation? Means here in place of 15, there could be 10 as well. So if all the pixels would be 10, then there won't be a color gradation. If there is no color gradation, there is no cross detection. Cross would not be detected at all. So that is why we are using -1 instead of 0 in our filter matrix. So whenever we are using -1, we are also taking into consider this 15 value or any other value it could be. So the right matrix for determining the cross, for detection of cross is this, isn't it? Because this will not take into consider whatever the adjacent values are there, adjacent pixel values. But by taking into this consideration, by taking this into minus value will also help us to detect what is the adjacent values of the pixel. So that is why, as I told that in age detection, we have used in this particular filter, minus value is very important, even if it is not the pixel value from 0 to 255, but it helps in detecting whether the particular filter is present or whether the particular filter is present over there or not. So I guess you have understood age detection topic, and I'll just give one another visualization, the same on the same side. Okay. So we have seen this, and you can see this. This is, and if you change the values, okay, I'll just try to change the values. And this is -1, -1, and I'll just tag 0 over here. And we will just tag 1 here. So as I change the values, the color, or we can see the filter is applied over this image, and accordingly we can see the change in the output image. Okay, so if I just remove this -1 and I just applied here, the -1 is applied over here, so you can see the output changes drastically. So you can see the input image, what was there, you have seen it, and how we have changed the output by applying a particular filter. If I change the filter to this, see, this is one of the filter, like left Sobel is one of the filter. So once you applied it, you can see that vertical edges are more detected. So this particular filter is for vertical edge detection, isn't it? So according to the change in the filter, the features which are extracted from the input image changes. So that is the most important step of before we learn all the layers of convolution neural networks. I hope you guys have understood this, and I hope you will understand the next topics, like in the layers in the convolution neural network.